Okay, so here we are on problem 5 on homework number 21, and we've got the reading speed of second graders is approximately normal with mean 89, that's our population mean, and standard deviation of 10 words per minute, WPM words per minute. So what is the probability that we will read more than 95 words per minute? So that's the probability that X is greater than 95. So because they do give us the population, they do give us the population mean and standard deviation. We are going to go ahead and this is where we just say 95 is our lower. We want everything greater than that, so we know that's 95 and out here to infinity. And so infinity we're going to call 1 times 10 to the 99. 89 is our mu, and 10 is our sigma, our standard deviation. And that probability comes out to be, when I put that in my calculator, 0.2743. It's 25, but that rounds up to 3 to the nearest 4 decimal places. So then when it comes to the interpretation, this one is less than 95, this one's more than 95, this one's exactly 95. So we want the one that is more than 95 because we were going for more than 95 here. So out of 100, so to the nearest hundredth place, we would expect 27 out of 100. Okay. Then for part B, what is the probability that a random sample of 10 second grade students? Okay, so now we're getting into the different sample sizes. Okay, so now we're getting into the sampling distributions. So a sample with a little n of 10 students with a mean reading rate of more than 95 words per minute. So we're talking about the probability that X is greater than 95. So really the only big difference on this one is that because we're doing a sample of 10, we can't use our population standard deviation anymore. It didn't matter for the mean so much. Remember, the mean of the sample will be the same as the mean of the population. It's more the standard deviation that changes because now this n down here becomes 10. Even though the standard deviation of the population stays the same. So this comes out to 3.16228. And so when I put this in my calculator, we're doing normal CDF with this time we're still doing more than 95. So 95 will be our lower limit. 1 times 10 to the 99 will be our upper. Our mean will be 89, and our standard deviation will be 3.16228. So I put that in my calculator, and it comes out to 0.02888898. So to the nearest 4 decimal places, 1, 2, 3, 4. I'll round this guy 8 up to 9, so it'll be 0.0289. Interpret this probability. We got to look at the word. So we're looking for more than 95 because that's what we had in our problem. This one's exactly 95. This one's less than 95. So we know it's not either of these two. It has to be A. And we would expect basically what? To the nearest hundredth place, that'd be 0.03. So that would be 3 out of 100. 0.03 is the same thing as 3 out of 100, right? Alright, so then in part C, what is the probability? Still more than 95. The only thing they changed this time is now our sample is 20. Okay, so since it's 20, we have to, again, we're doing a sample, which is our key that changes the standard deviation. The mean doesn't change, it's still 89. But the standard deviation, now we're dividing by the square root of 20. So 10 divided by square root 20 is going to be 2.23607. So we're going to go put this one in our calculator. So we're looking for the probability that X is more than 95 in a sample of 20 would be normal CDF still have 95, still have 1 times 10 to the 99, still have 89. The only thing that changed is this standard deviation is now 2.23607. So let's put that in our calculator. Okay, so that one comes out to be approximately 0.003645. So 4 decimal places, 1, 2, 3, 4. So we're going to say 0.0036. Again, we're going for more than 95. This is less than 95. This one's more than 95. This one's exactly 95. So it can't be either of these. It has to be more than. And we're looking at to the nearest hundredths place. I mean, really 0, to be honest, because that's not going to round up at all, because that 3 is not more than 5. Alright, so moving on to part D. What effect does increasing the sample size have on the probability? Okay, so our options here are increases or decreases when it comes to the probability as n increases. So we already know, we talked about in class the other day, that the larger your n is, when n is large, your standard deviation gets smaller, and that when n is small, then your standard deviation is larger. You're going to have a wider, flatter curve, versus if your n is large, then your bell curve is going to be skinnier. And it's because, I mean, just think about it. The more people you survey about something, the closer you're going to get to the actual mean that you want, versus if you were only to survey 2 people, well, your 2 people may be way out here, or 1 way out here. I mean, who knows? They could be any combination. And so our probability decreases because the standard deviation decreases as n increases. So that would be at B. Alright, and now we're ready for part E. We have a new reading program, 10 weeks into the program. The mean is 22, so that's our X bar. I'm sorry, 22 is our number of kiddos. 22 kiddos. And our mean is 91.2. What might you conclude based on this result? Select the choice below. Okay, so first of all, we have to adjust our mean and standard deviation. Well, I mean, our mean's still the same, right? It's still 89. Our standard deviation, we have to divide by 22 is our new n. And so 10 divided by the square root of 22 comes out to 2.132. And what we're really looking for, if you read this closely, they're really asking, is it more, what is the probability of obtaining a result of 91.2 or more? Okay, so you got to really look at what you're looking for. So the probability of 91.2 or more, we're going to put that in our calculator with our normal CDF. If we're going out to the right, we're doing 91.2, so here we are, and we're going out to the right. And so then our, this is out to infinity, so 1 times 10 to the 99th. Our mean is 89, and our standard deviation is 2.13200. And so when I put that in my calculator, I get approximately 0.15106. So to the nearest tenth place, that is 0.1511, which is reasonable. It's more than 5% probability. Remember, it's usually, so we would say it's not unusual. It would only be unusual if it was less than 5%. And so out of 100, we would expect to the nearest hundredths place 15 out of every 100. All right, and then our last one is part F. there's a 5% chance that the mean reading speed of a random sample of 22 second grade students will exceed what value? So since they gave us the 5%, this is when you inverse norm, is when you have the percent, you have the area under the curve or the proportion or whatever you want to think of it as. That's when you inverse norm. Now remember with me, inverse norm is not one that plays super nice. This number is always to the left of the percentage. And so we have that number. Then because we're still dealing with 22, our mean is still going to be 89 and our standard deviation is still going to be this 2.13200. Let's think about for a minute what number is going to go here. So we have, here's my curve. I want to know the 5%, top 5%, because we want to know that what they'll exceed what value. So what is the number right here? What is the top 5% of our population? So since this is to the left of the percentage, we're looking for this percent, right? So instead of the 5%, since this has to add up to 100, this will be 95%. So when you go put this in your calculator, be careful that you put 0.95. Okay, and then when you put that in your calculator, it tells you that a 92.5, 2 decimal places, so 0.51, 92 point, here, I'll put it here in the blank, 92.51 is the score. Above that is going to be your top 5% of readers, at least in speed.